Assalamualaikum and good day everyone. Today we are going to continue with our lecture Engineering Math 2. We are going to continue the subtopic that we have not covered last Monday, which is the optimization of constraint function. Optimization of constraint function. Okay, the difference between this subtopic with the previous subtopic is the previous one we consider about the unconstrained functions, where there is only one function, which is f x y z, for example, if there is 3 dimension. But in this subtopic, we are going to consider the f function including the constraint. The constraint can be a function. Usually the constraint is a function, and we denote it by g. So if the main function has 3 independent variables, so g also, the constraint also has 3 independent variable, x, y, z. Alright. Okay. So without further ado, we are going to go through an example, which is example 9.41. This is in page 773. So for those who have book, you can look at the example. Okay, now how we solve this problem. Usually we will solve this problem in a simple way. So I will show you 2 methods in solving this example, the problem in the example. Okay, so the problem is we need to obtain extremum, which means the maximum point or minimum point or saddle point, maximum value of the function f x, y. So in this function we have 2 independent variable, so 2x square plus 3y square. Alright, but we have a constraint. So the constraint is constraint function is 2x plus y equal to 1. Okay, so I will use the simple method first, but this simple method cannot be used in all problem. The range of usage is limited because not all problem is simple, and we need to consider a general method which can cover many kind of problems. So for the first method, I'll show you how to use it. So for the answer, first we can directly eliminate for example y by using the constraint function. Okay, so first we use the constraint function and arrange it so that y is in terms of x. So when we arrange it, y is equal to 1 minus 2x, right? So we can substitute this into the main function, which is this one. Okay, so substitute. Alright, so what happen is f x y will be equal to 2x square plus plus 1 minus 2x square. Alright, so when we elaborate this, we will have 2x square plus 1 minus 4x plus 4x square. So the final answer will be 14x square minus 12x plus 3. Okay, this is the function, a new function which has constraint. So we have include this constraint inside the main function. So this is the outcome. Okay, so what we do next is we need to find the extremum. So we need to differentiate this function. So f, the first derivative is, so this is in term of x. No, yes, this is in term of x. Since we have eliminate the y, so we only differentiate in term of x. So the answer is 28x minus 12, right? And then for this function, we find it because we want to find the value of x when the gradient is 0, which is the stationary point. Okay, so but we need to have another the second derivative to know whether it is a maximum point or a minimum point. Okay, so we do the second derivative. So this will be 28, right? Okay, so from this function, this equation 2, so when we equal it to 0, so 28x minus 12 is equal to 0, so we will get that x is equal to, you can calculate it by yourself. The answer is 3/7. Okay, alright, so this is the point where the curve of the function is stationary. So this is the stationary point. Okay, and now when we look at this third this second derivative, the value is positive. So when we know that the value is positive, it means that this is a minimum point. Okay, So how to find the value of y? Simple. We know the value of x right here. So we put it inside this equation, and therefore we will get that y is equal to 1/7. Okay. So problem is solved. Alright. But this case is for method, which is limited to simple problem. But if there is a constraint which is complex, or sometimes the constraint cannot be solved because the constraint does not overlap with the main function. Therefore, we need to make sure that the constraint is overlap with the main function. So that's why we need to learn also the next method, which is alright. So the next method is we will use the formula. Actually, there is a derivation of the formula in the book, but I will go straight to the formula because and you can learn about the derivation of the formula by yourself. Okay. So like I said, we have the main function f x, y, and z, and we have the constraint which is g, x, y, z. So this is the main function, right? Okay. So there is a formula. We call it auxiliary function. So auxiliary function is like this. The symbol is this: x, y, and z, and this is equal to the main function x, y, z minus lambda g. So this is the constraint x, y, z. So why do we need the lambda? Because we want to adjust the constraint, the g, so that it is overlap with the main function. Therefore, the constraint is suitable with the main function. So, and for the lambda, what is lambda? Lambda is the Lagrange multiplier. Okay. And in order to find the stationary point from this auxiliary function, we need to have the condition, which is delta, we call it psi, delta x equal to delta psi delta y equal to delta psi delta z, and everything is equal to 0. And also the constraint g, x, y, z is equal to 0. Alright, so this is the condition to find the stationary points, right? Okay, in order to understand it, we can apply this method into the same problem just now, which is example 9.41, but in the book it applied the method in example 9.42. So we go to example 9.42. Okay, so I'll show you how to apply this method. So we have the same function f x y equal to 2x square plus 3y square, and the constraint is g x y equal to 2x plus y minus 1, and this one is equal to 0. Okay, why? Because it is stated here in the method that this one should be equal to 0. Okay, so now okay, before we go we use the method, I will show you how this function look like if we illustrate it in the graph. So if you look at here, this is the oval, which is the main function, where 2x square plus 3y square equal to any value. So this value can be anything because this is the function. So it can be 0.5, it can be 0.64, it can be, and the one that we found is the value is equal to 3/7, this one. And from this line, from this value, this is the suitable value for the constraint. If we use other constraint, if we use other value 0.5, 0.64, it will not overlap with the constraint. If you look at here, this is the constraint, y plus 2x equal to 1. So this is the constraint, and if you look at this line, it's overlap at the minimum point when the value of the function is 3/7. Alright, so that's why we need to have this method, so that we will not use other oval, we just only use the oval with values 3/7. Okay, and from that from this value we can find the minimum value. Alright, so we go back to the equation. So we can apply the auxiliary function, which is psi x y z is equal to f x y minus, so it is minus minus lambda g x y. Alright, okay, so we can substitute the function. So we will get that 2x square plus 3y square minus lambda, what is the function, 2x plus y minus 1. Okay, why this one is different with the previous one? Because we need to make sure that this constraint is a function with equal to 0. So that's why when it is equal to 0, we need to take the 1 to the other side, so we will have this function, and this function we replace it, and this function is equal to g. Okay, alright, so from here okay, to find the stationary point, we use this formula. In order to find the stationary point. Okay. So first we find the partial derivative of psi. So in terms of the x, so this one is 4x minus 2 lambda, right? And partial derivative of y, in terms of y, 6y minus lambda, right? So both of them should be equal to 0. All right. And again, we need to emphasize, to find the stationary point, this one is should be equal to 0. The constraint should be equal to 0. All right. Okay. And by solving this, by using these three function, we can find that the value, we can find the value of lambda, the value of x, and the value of y. Okay. And how to solve it is by replacing, by finding, for example, the lambda first, and then we replace with, for example, this one, this equation, x is equal to 2 lambda over 4. Okay. And then we put this function into the third function, so it will be 2 lambda over 4 plus y minus 1 equal to 0. So what happen is lambda plus y equal to 1. So maybe we want to find y first. So y is equal to 1 minus lambda. Alright. So we replace this one with the second equation. So we go to here. So 6y is equal to 1 minus lambda, and minus lambda equal to 0. So we can get that lambda is equal to how many? So I calculate it. 6 lambda minus lambda is equal to 7 lambda, and 6, we have 6 right here and here, like this. So lambda is equal to 6 over 7. Alright. Okay, when we put this value inside these three equations, and we can get the that the lambda, lambda is equal to 6 over 7 just now, and we can find that x is equal to 3 over 7, and also y is equal to 1 over 7. Okay. Alright, so this value is the stationary value, stationary point, right? Okay. And now we want to know what is the nature. What is the nature of the stationary point? Whether it is maximum point or minimum point or saddle point. But since this is only, there is only two we call it independent variable, so there is no saddle point, so whether it is maximum point or minimum point only. Alright, so how to find it? Actually, from the diagram I shown just now, we can know that it is a minimum point. But in order to confirm it, we can use the Taylor theorem and consider the sign of the difference. Okay, I'll show you. First, in this method, to find whether it is maximum or minimum, we can calculate f. We need to find this. We take a point near to the point, the stationary point. So the stationary point, if we combine it, we can have that. This is the point. So the point near to the stationary point is 3/7 plus h and 1/7 plus k. Okay, so this is the point near to the stationary point, which is next to, not before, but next, when we add the value of h and k to x and y, so we get the next point. Okay, so you want to know the difference between these two value. When we put this value into the equation, we will get the value of f1. Okay, for example f1, and when we put another value into the equation, I mean the main equation, this one, okay, we will get the other value, which is f2. Alright, so to find whether it is increasing or decreasing, we need to see whether f2 minus f1 is negative or positive. Okay, if it is positive, when it is positive, it means that the value is minimum, because f2 is bigger than f1. But when it is negative, that means the next point is lower than the point that we found, this one. So when this point is bigger than this point, that means this is the maximum point. Okay, so negative mean maximum, positive mean minimum. Okay, so okay, how to find it? First, we simplify by using the constraint. So the constraint function, remember, 2x plus y minus 1 is equal to 0. So we put this value inside the constraint equation. So 2x is 3/7 plus h, plus y is 1/7 plus k, right, minus 1 equal to 0. So 6/7 plus 2h plus 1/7 plus k minus 1. So this one add with this one and minus this one is eliminated, equal to 0. So we have 2h plus k equal to 0, and we can now simplify. K is equal to negative 2h. Alright, so now we can eliminate the k. So the new point is 3 over 7 plus h, and 1 over 7 minus 2h. Alright, from this one. Okay, so now we can put this value inside the equation, this one, this equation. So let's say this is star. So star is equal to f x plus h y plus k minus f x y. Okay, so now when we put the new point, so f 3 over 7 plus h, this is the new point, 1 over 7 minus 2h. So remember, this is the value of x, this is the value of y, sorry, minus f 3 over 7 and 1 over 7. Alright, now we can do some calculation. We want to see whether this, what is the value of this. So we will have to, we put inside the equation, the main equation. Again, I show you again. Alright, it's far away. Take some time. Okay, this one, this equation. So also this equation. Okay, so when we put this value, so we will get that to uh, 3 over 7, we do it quickly, plus 3, 1 over 7 minus 2h square. Okay, and this is f1, and for f2, 2, 3 over 7 square. I mean, this is f1, this is f2, sorry. So, and 3, 1 over 7 square. Alright, so we can simplify it, and finally we can get that the value is this one. So h is, it should be positive. So when we square it, and whether it's negative or positive, it will be positive. So this one is bigger than 0. So when it is bigger than 0, it means that what? It means that it is the stationary point is minimum point. Alright, so this is similar, the answer is similar to the previous method, which is this one, where we get the minimum point also, and the point is the coordinates also 3 over 7, 1 over 7. Alright, same answer, but complex method, but more applicable in real problem. Alright, okay, so this is that's all for this example. Now we can go to the next example, example 9.43, so that we can see different application of the method.